Hey guys, so today we're looking at our absolute value functions. After our last lesson on the square root function, I do find these are a little bit nicer. So if you're a bit worried, don't stress, it's a bit nicer today. So let's think about what our absolute value graphs could look like. There's two different types that they might ask you. You could be asked to draw the absolute value of the entire function, or you could be asked to draw it in this second form here. Okay, so they're your two types, but the idea is simply that if I gave you anything that would give me a negative answer, it's just going to make it back positive. Okay, so that's the idea with this, the absolute value. It takes anything negative and makes it positive. So, now my pen's working. So the difference between these two types of graphs is the first one might say to graph the absolute value of, let's say, 2x minus 1. So that's the first one. But the second one, so that's this type, the second one might look something more like this. Graph the absolute value of 2 timesing by the absolute value of x minus 1. See the difference there? That's the difference between these two that I have put on here. So let's think about the difference between them and what gets affected. With that first one, we know that taking the absolute value of something turns it into a positive term. So that's what I've written here. It's just going to make everything bigger than or equal to 0. All right. So if you think about our classic y equals x graph, it takes anything in that negative region and makes it positive. So all of these negative answers down here get flipped up and made positive, which give you the absolute value of x. So that's where I've said here, it just flips any of those negatives along the x-axis, and for some reason I've written it twice and I don't know why, but it flips anything on that x-axis around up into that positive region. So now let's look at the second case, all right, the one where it's taking the absolute value of x individually. So let's think about how this might affect it. It's going to be the exact same graph for any of the positive x values. Okay, so for this graph here, on my positive x-axis, it's going to be the exact same graph as 2x minus 1. So let me just draw 2x minus 1. So if I just draw in blue, y equals 2x minus 1. Let's think about that. All right, it's going to pass through at positive a half, so I'll make that a half, and at negative 1. It's going to look something like that. So what it's saying is, for all of the positive x values, it's our absolute value, so this green graph here, it's going to be the exact same. So from 0 onwards, we have the exact same graph. So passing through a half and coming up here, because nothing changes. But then all the negative values that we would have subbed in here, they would have become positive when you put them up into the absolute value and then put into the equation, which is going to give you the exact same answers as what was on the right hand side. So that is simply going to become that. So notice how it just flipped along the y-axis. Okay, so it's going to be the same function as your original for all your positive x values, but it will be a different function for all the negative x values as the original. Okay, all right, so let's see. I didn't really think this through, did I? Hang on. So now that I've scribbled all over my PDF, here's the example with a little bit more information, and this time I've done 2x plus 1. So the first thing I did is I said, all right, let's sketch 2x plus 1, and we know that's just our straight line passing through at those intercepts. So then I said, okay, well now let's draw 2x plus 1 as an absolute value. So then I said, all right, well I know the absolute value of that entire thing takes anything in that negative region and bumps it straight back up into the positive region. In other words, it flips all those negatives on the x-axis up into the positives. So then the absolute value of just x on its own in that equation, it's the exact same graph. So I've drawn it coming out from 1, the exact same graph as the original on the positive x-axis, but then it just flips perfectly all those negative values in your negative region into the positive side. Okay, so let's have a look at a more difficult example now. So let's see what I've drawn here. So I've started with our parabola. So I've gone in and I've drawn you this parabola here. And it's actually it's the same parabola we just did in our previous lesson on square root functions. So we've become familiar with it. We know that passes through at -1/2. All right, so the absolute value of that, once again, go through any negative values, flip up the x-axis into positive. So see how we have negatives, negative, so they become flipped up, positive, and positive. Okay, so I've taken the absolute value, makes everything negative, positive. So the next one, it's a little bit hard to see, but it's just that same equation, but it's taking the absolute value of x each time. So now let's think about that. In our normal equation over here, we know that our graph is going to be the exact same for all our positive x's, but then it just flips everything perfectly into the other side along our y-axis, which gives us this graph here that I've drawn. Okay, so it's a really straightforward thing to get your head around, especially compared to our last lesson. So I've just given you one more example here. All right, so again, this is now where we're bringing those cubic terms into it. Okay, so we're going to start by sketching it. So pause the video now because I really want you to get good at being able to roughly sketch this graph here. Okay, remember x-intercepts, y-intercepts, and then the general overall look of the way the cubic goes. So draw that, pause it, and make sure you get your value to look like this in the end. Alright, so now what I need to draw is the absolute value. So the first thing I'm going to do is go, okay, all my negatives become positive. So I'm going to bring that up here, and I'm going to bring that up here. So my absolute value graph will just be that yellow. Okay, so that's the graph of B. But then, this next one wants you to draw the absolute value of just the x part. Okay, so again, I'm going to take out my B again. Let's go back a step. Here's my original again. Now I know that it's the exact same graphs for all my positive x region, and that just has to be reciprocated perfectly on the other side. So there is my graph for C. Okay, so that's just what I've drawn down here in my sketch. Okay, so it's not a difficult concept. All right, give those exercises a go. So we're on 709. I want you to give all of question 1 a go for me. All right, and I will see you next week.